I study animals that live in sediments and sort of the ecological role that they play in their environment. So probably the most commonly known thing is that they're fish food, and so a lot of people care about them because they feed on the organic matter in sediments and then wrap it into a nice tasty worm, and then the fish eat them. But they also do what worms in your garden do. So they mix the sediments around and bring oxygen down, and they regenerate nutrients, and that can be really important in terms of what they pee and poop out. Regenerates nutrients that then fuel phytoplankton growth, and that's really important in shallow areas like Mobile Bay and the coastal environment here. I got really interested in worms because they're very ecologically important, but it's very hard to study them because they live in mud and you can't see them. And so in order to be able to study them and understand what they're doing, I had to come up with a lot of kind of new techniques and figure out how to study something that you literally can't see. So in order to do that, I've had to learn a lot of engineering techniques and apply those both in developing new methods to observe them and also kind of understanding some of the engineering theory that I then apply in my work. So I collaborate with engineers, and I took a lot of engineering coursework, so I have a strong engineering background, but I'm really a biologist who kind of dabbles in engineering. I'm not a legitimate engineer. When I was in graduate school, I found that worms actually burrow through muds by cracking their way through. So people had thought about worms sort of eating their way through mud, but in fact, the mud is very cohesive, so it's kind of like Jell-O. And so I actually used Jell-O as a transparent analog for mud. So I spent several years making giant vats of Jell-O and then sticking worms in it and watching them move and thinking about how that related to what they do in mud. And so what they do is they actually push against the walls of this crack-shaped burrow, and knowing a little bit about fracture mechanics helped me understand that they do that, and what the forces that they apply are actually amplified at the tip of the burrow, and it causes the burrow to open up, and so they can move forward into that space. And that was really important because people had thought about burrowing as being really energetically expensive. Like moving through dirt does not seem like a good way to move. Like we run and we swim and we do all these things that are much easier than that. And so there was this sort of big question of why would they bother to burrow if it's that hard? And so my research has showed that it's not actually as hard as people had thought, which kind of helps us understand why there are so many different organisms that burrow in sediments and that live in this habitat. So I think one of the coolest things about what I do is that it's very interdisciplinary. So, I got interested in it because of biology, but as a kid was always very good at math. But I didn't really realize that my math skills were important in the biology that I was interested in. And so once I kind of realized that, like around high school, as I was learning more about marine science, I was like, oh, I really need to pay attention in math. I can't just coast through because it's not that hard for me. And so I didn't have a good understanding at that age of how much of all of the different things I was learning would tie together in what I do now.